Yesterday we saw how to differentiate the trig, so now let's go back the other way. How do we integrate the trig? If we have cosine, and notice I've just put a linear function here, then, well, when we differentiated cosine, we got negative sign. However, when we integrate cosine, we'll get positive sign, because of course when we differentiated sine, we got cosine. Because I'm dealing with a linear function, it'll be multiplied by 1 over the coefficient of x. So sine now will be the one that goes to negative, because when you differentiate cosine, you got negative sine. Therefore, when you integrate sine, you'll get negative cosine. And for integration, well, it's sec squared that we'll end up integrating, because we know that'll go to tan. So these formulas here are for linear functions. Any other type of function, we just want to use that idea like we did with exponentials and that, where we want to create the derivative of the angle out the front. So let's look at a few examples. Sine 3x, 3x is a linear function, so I can go a third and it'll be minus, because we're integrating sine, so minus a third cosine 3x. Again, we have a linear function. Now, when we integrate cosine, it goes to sine, but the coefficient of x in this case is negative. So we'll get negative 1/5 sine 1 minus 5x. That's also linear. Coefficient is a half in this case, so 1 over a half is 2, so 2 tan x on 2. Let's do a definite one. So sine goes to negative cosine, so we've got negative a half cos of 2x. Subbing in pi on 2, that becomes cosine pi. Subbing in pi on 6, cosine pi on 3. Cosine of pi is negative 1, and cosine pi on 3 is a half. So we end up with 3/4. All right, here's one that's not a linear function. So as I was saying, we want to use that idea where let's create the derivative out the front. So we've got x squared, so what we'd like to see is 2x. So let's make it 2x, but balance it out. We'll put a half out the front. I now have derivative sec squared of the angle. So sec squared will go to tan. We'll get a half a tan of x squared. Sine squared, they love asking sine squared or cos squared. You can almost guarantee it will appear in every HSC somewhere in some form. Might not be x, might be 3x, could be, but sine squared, cos squared. Comes from the double angle results. And if you recall, cos 2 theta could be written a couple of different ways. It's cos squared minus sine squared. But we could rewrite it as 1 minus 2 sine squared. Now, you may not remember, but last year I said, actually, when we make sine squared the subject, this will become very useful. It's now very useful. So sine squared, I can change to a half of 1 minus cos 2 theta. Incidentally, if it was cos squared, we had to integrate. It'll be a half of 1 plus cos 2 theta. But sine squared we want. So now I'm going to integrate 1 minus cos 2x, and everything's fine. Cosine 2x we can do, and 1 obviously we can do. So we get a half of x minus a half sine 2x, and just tidying that up, I've left it as x on 2 minus a quarter sine 2x. So sine squared, cos squared, use your double angle results to integrate those. Now we didn't do the integral of tan, because of course yesterday nothing differentiated to give tan, but we can do it. If we rewrite tan as sine on cos, we now have the situation of derivative on function. Well, almost. The function is cos x. The derivative of cos x would be minus sine x. So let's make it minus sine x. So I'll need a negative out the front. I've got derivative on function. That's a log situation. So it must be minus the log of the cosine of x. Some people prefer to bring the negative into the log, so it's just a nice neat log, which is fine. So it'll be cos x to the power of minus 1, and the reciprocal of cos is, of course, sec. I mean, either answer is acceptable. So minus the log of cos or the log of sec is our integral of tan. Cos x sine to the power of 7x. Now, hopefully, we see it straight away. And we go, hang on, this is like we've done the chain rule. We've almost got the derivative there. In fact, we have got cos x, but we haven't brought down the power and so on. So it's very close. If you spot it straight away, it's going to be quicker. The other way, of course, is doing it by that substitution idea. So the power is on the sine. So if I let u equal sine x, then du would be cos x dx. But if I'm changing the variables, I'm going to have to change those limits because they refer to x, not u. So when x is 0, u will also be 0. But when x is pi on 2, u will be 1. And we can now rewrite that as the integral from 0 to 1 of u to the power of 7. Add 1 to the power over the power, substitute in, and we have our answer, 1/8. 2020 HSC paper. Integral of cos 5x times sine 3x. This is where our products to sums is going to come in useful. So we can rewrite the cos of 5x sine 3x as a half sine the difference plus sine the sum. So 5 and 3 is 8. Now you might see I've got minus 2x there and not 2x. The reason why is actually we're used to seeing it as sine cos, not cos sine. So I'm actually going 3x minus 5x. So I get minus 2x, but sine is an odd function. So that's the same as minus sine 2x. Now I can integrate. Substituting in, we get our answer. Now remember, in the HSC, you're given those table of different formulas and what have you, and I'm pretty sure the product to sum formulas are on there. So if you're unsure, check, make sure you check and get it right. That'll do us.